Let's explore the fundamental architecture of Git. We'll cover Git's three-tree architecture and its object model. Understanding these concepts is crucial for effectively using Git for version control. Git organizes your code using a three-tree architecture. These trees are the working directory, the staging area, and the repository. The working directory contains the files you're actively editing on your file system. This is where you make changes to your code. The staging area, also known as the index, is where you prepare changes for your next commit. You selectively add changes from your working directory to the staging area. The repository, also known as head, is where Git stores the committed history of your project. It contains all the snapshots of your files and directories over time. Now let's examine the key Git commands for moving changes between these three trees. To move changes from the working directory to the staging area, you will use the git add command. Typing git add, followed by a specific file name, adds that file to the staging area. Alternatively, git add adds all the changes in your working directory to the staging area. To move changes from the staging area to the repository, you will use the git commit command. Typing git commit'em, followed by a message, commits the staged changes to the repository. The message provides a description of the changes you're committing. Git commit m, followed by a message, stages all tracked files and commits them in one step. To move changes from the repository back to the working directory, you will use git checkout and git restore commands. Typing git checkout, followed by a branch name, allows you to switch to another branch. Git restore, followed by a file name, discards changes made in the working directory and reverts it to the last committed version. Git stores all repository data as 4 types of objects. These are blobs, trees, commits, and tags. Blobs store the actual file contents. Trees store directory structures representing the hierarchy of files and subdirectories. Commits store snapshots of the repository at specific points in time, including metadata like author, date, and commit message. Tags store named references to specific commits, marking important releases or milestones. All of these objects are identified by a unique SHA-1 hash of their content. This makes Git a content-addressable storage system where data is accessed based on its content rather than its location. Let's take a look at how to view these Git objects. To view commit objects, you can use git log one-line, which shows a concise history of commits with their SHA-1 hashes and commit messages. Git catfile p, followed by a commit hash, displays the content of the commit object, including the associated tree, parent commit, author, committer, and commit message. To view tree objects, use git catfile p, followed by the tree object hash. This shows the files and subdirectories contained within the tree, along with their corresponding blob or tree hashes. To view blob objects, use git catfile p, followed by the blob object hash. This displays the actual content of the file stored in the blob. Git's commit history forms a directed acyclic graph, or DAG. Each commit points to its parent commits, creating a chain of snapshots. Branches are simply pointers to specific commits, allowing you to work on different features or bug fixes in isolation. Head is a special pointer that always points to the current commit you're working on. Merges create commits with multiple parents, combining changes from different branches. This structure allows Git to efficiently track project history and supports branching and merging workflows. Let's explore some essential commands for working with branches. Typing git branch lists all the branches in your repository with an asterisk indicating the currently active branch. Typing git branch followed by a branch name creates a new branch. Typing git checkout followed by a branch name switches to the specified branch. Typing git checkout b followed by a branch name creates a new branch and immediately switches to it. To merge branches, first switch to the target branch you want to merge into. For example, git checkout master switches to the master branch. Then, type git merge followed by the name of the branch you want to merge. Finally, type git branch d followed by a branch name deletes the specified branch. Git uses references or refs to track important positions in your repository. Branches are refs that move forward as you add new commits. Tags are permanent refs that mark specific commits, typically used for releases. Head is a special ref that points to your current working commit. The ref log is a history of where head has been, allowing you to undo accidental changes to your branch. All of these refs are stored in the .git/ref/ directory, and the current head is stored in .git/head. In summary, Git uses a three-tree architecture: the working directory, staging area, and repository to manage changes. Git stores data as content-addressable objects including blobs, trees, commits, and tags. Commits form a directed acyclic graph that represents your project's history. Branches are lightweight pointers to specific commits, and head is a special reference that points to the current commit. Understanding Git's architecture helps you use it more effectively and troubleshoot any issues you may encounter. Here are some further resources to deepen your knowledge of Git: the Pro Git book, Git internals, and the official Git documentation. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.